indication that everybody is not working, meaning that there is a gap. Okay, uh, I don't think that they are allowed to smoke or there is a smoking time, but they are doing it anyway. So that means again like there is a lot more people working in there than what you need. In the past, I did some work on Indian banking. And now, since I have personal experience with Indian banking, so you go to the bank and you see that there are so many people working in there. And then you can clearly eliminate a lot of them. Why you are not doing that? Because most of the banks are personalized, right? So the government is saying that, okay, they're saying that go and hire people even though the bank does not need any more people. Okay. Sometimes I go to a store, and this is somewhat, again, my personal experience. I just went to a store and I see that there are salesperson everywhere, and they're chatting with themselves. And I'm going in there and I'm asking, what is this product? He said, well, okay, aisle number 6. And I said, well, what is aisle number 6? And I turn around. So they're supposed to be taking me to aisle number 6 and pointing out the product because there are so many people in there, but they're chatting with themselves. So this is kind of an indication that again, resources, meaning human resources in there, are not efficiently used. Right? Um, so you'll see those type of things everywhere. And since again, it's not that well, I do research on those things by what I observe, and I just see that again. If I want to give an example, then what sort of example I can give? And again, one time I was in Tokyo. So then again, I noticed that well, after getting out of the plane, you have to take a bus because the city is quite far from the airport. So I was instructed that well, take bus number 3, for example. So I was just standing in there, everybody queues in there, so Japan, right? And then I just saw that well, the bus comes and stops. This is kind of mini bus, small bus, and there is somebody. I don't think it was a driver, someone was taking the bag and putting it there. And you know the way he was putting the bag is just like the way you would put your own bag, meaning that well, not like in the US, you just take the bag and throw it inside. Okay, so it's just holding it like this and gently putting it down. I observed it, and again I gave a seminar. Afterwards, so I gave that one that well, look, this is how they do things in Japan. And when we were talking about again efficiency in the use of resources or labor, you can see that that immediately the bus comes, immediately this guy comes from nowhere. I did say it before, and then he just started tagging those things. Right? So you observe many different things again, like the way things are done. So one is what we call this one is output oriented, because this is measured in terms of output shortfall, okay, and this is called input oriented because this is related to input overuse, right? You can think of inputs here X as resources, right? So the question is that so the question is whether the resources that you are used can be cut down without cutting down production. And this is happening all the time. And again, another example is that we always argue that, for example, a country is poor because the resources are not enough. Right? So in development economics, that course I took many years ago in India, this one India is poor because we don't have enough resources. But now I argue that well, yeah, I agree that resources are not enough. But the point is that um, the point is that again, whatever resources you have, are you using that in an efficient way? That is my question. And what is your answer? Do you think that resources are used in an efficient way? No. You get money from the central government. How much of that money is being used? Okay, so you all know that on the way coming from Delhi to even in here, it started long distance. Something is just getting on the way. That means this is resources are being leaked. Leaked meaning that somebody is taking some part of it. Maybe you are granted in 5 lakhs, but 1 lakh goes to the people who are working in that agency, and then again ultimately the amount that you get maybe 70% or 60% of it. Okay. So the point is that well, it's just not the resource scarcity. Okay. The point that I would like to emphasize is that well, I would like to see whether the resources are optimally used. Okay. So another case, since I'm just talking about this thing because again, like a technical side, I won't go into the details. So again, think in terms of using data to see that which states in India, okay, are doing well. So think in terms of GDP, okay, and then again, like think in terms of infrastructure, capital, labor, and that type of thing, estimated production function, and then you rank the states, okay. Um, I don't know which state would be ranked first, but again, like this is I don't want to talk about the state level, but again, this is something that people do talk about. The other day, I was looking at the newspaper, and they were saying that well, Bihar, we're supposed to say that well, Bihar is economically worst, right? But now I said that well, Bihar is taking taking the lead, and in terms of your IAS, IPS, and those type of exams, Bihar is not lagging behind. Um, so the point is that you can always do this type of thing, and then if you have a time series data, you can just see what is happening to efficiency over time. Okay, you don't say the well Bihar is really backward. Well, it was backward 20 years ago or 30 years ago, but the question is it still backward, right? And again, when you say backward, relating to what? Okay, so I said, well, if you do a frontier type thing, and then in the rank, Bihar was maybe Bihar would be in the lowest rank 30 years ago, but now it's not the lowest one. So this is kind of usefulness of this type of studies. So you need to get data on whatever level you have, either state level or again the municipality level or district level, and then again like you do a comparison. You pick a benchmark and then you compare every observation relative to the benchmark. So there are tons of things. The type of things that I do are not in the aggregate level. I tend to work with the individual data using micro data. So using farmers, for example, I don't have data from India. I use data from Norway because I have some authors from Norway and they have also farm level data. But again, like if you can get farm level data in India, I know that there such data sets are available. But since I don't have the connection in India, I don't work with it. I have nothing against working with Indian data, but somebody has to get the data. Okay. Uh, so again, a friend of mine who works with Indian data is he knows people. Okay, not only getting data but also professors with whom he works. And I don't have that many people I know in India with whom I want to work. So again, like given the data, I mean, if you can collect some data, then or you can use this type of benchmarking exercise to again compare the states, how the state is progressing over time. Okay, that would be kind of an interesting thing to study because as I said, well, I know that again people just say, well, Bihar is Bihar. I mean, nobody wants to talk about it because it's so bad. I think the joke was that at some point, this is really a joke, that Pakistan was thinking in terms of taking over Central to India, that we want Kashmir, in the whole Kashmir. And in the end, there was the prime minister says, okay, no problem, we'll give you whole Kashmir, but you have to take Bihar also. No. So no. That was the end of that. So this is the kind of the joke to just say that this is a joke literally to say that well Bihar was so backward that nobody wants to be associated with Bihar. But now again it's a different case type. So then again the interesting point is just to see how the state is improving and how, for example, West Bengal, okay, was claiming West Bengal was claiming or Bengalis will claim that well, we are in the top, but it's nowhere in the top. I know because I come to Calcutta pretty much every year and I see how things are going down instead of going forward. Right? So this would be kind of an interesting study to do. Okay, so now again, mathematically, when you just look at this graph, okay, um, um, so 20 minutes, you said, so again, so basically, I'll stop, what, at 5, or whenever it says that. Okay, so this is the graph. It says that while you have output shortfall is given by the maximum and the actual, and this is the input overuse. So the question is mathematically, how do you capture this? Okay. Um, so again, like if it is input oriented, you can do it like this. So y equal to f of x, and then you multiply by a factor which is less than 1. Please remember, if this is 10 and you know that you can produce the output with 8, so you have to multiply in a 10 by a scaling factor that's less than 1, right? So 10, and then again I multiply by a factor to make it 8, right? So what you do is you multiply by 8 over 10. So that is the point. So this e to the power eta is the such factor. So eta is positive number. So e to the power negative number is less than 1. So we just do it like this. Okay. And we do e or exponential because we take a log and that will make it linear. So that's kind of the reason why we're taking exponential function. Okay. And then for so the input oriented inefficiency is like this. So for output oriented, we write like this: y equal to y star. Y star is the maximum possible output. That's f of x. Remember that point, big B, and on the top of the line. And then again, like if you are inefficient, you are producing less than that. So your y star multiplied by a similar factor, and this is less than 1. So again, u is being positive, and e to the power minus u, meaning that well, this is less than 1. So you are multiplying by a factor that is less than 1 to make it equal. So basically what would happen is that you have y less than y star. So the question is that you have less than, how do you make it equal? How do you convert the inequality sign to inequality sign? Well, I mean, this right hand side is less, so I mean bigger, because again y is less than y star. In other words, y star is bigger than y. So what you do is you just scale y star down. Okay, this is heavier than this, and that's why we are just multiplying by e to the power minus u, which is less than 1, to make it equal. So if something is you have two sides, one side is bigger than other, you can make them equal by what, adding something or subtracting something. But instead of adding and subtracting, here I'm doing multiplying by something. Okay, because again I'll be taking log, so that when you have multiplicative sign taking log, meaning that it becomes additive. Okay. So then again, you just write it out. Y is equal to so y is equal to f of x. This is the frontier part, and then e to the power minus u is that this efficiency. So e to the power u, meaning that our efficiency is not never going to be greater than 1. So if it is less than 1, then again you write it this way to make it equal by taking log. So I'm just doing it like this. So what is u or minus u? This is the measure of inefficiency. Okay. And so what we will be interested in is estimated u. Okay. Okay, so this is again this is the part that we have so far, and then again what is this f of x? Now this can be represented by a parametric function. You can think in terms of this Douglas or translog. I am not sure whether you have heard the word translog, probably not. But again, this is kind of a second order approximation. So let's just think in terms of Douglas, which is linear in log, right? So you can say that well, this is linear in x, and then again this is u, which is one-sided, meaning that positive number. Now remember at one point I was talking about noise time. That means you cannot talk about the discrepancy without introducing noise. So the stochastic frontier that was introduced in 1977, where basically argues on at that point. that the relationship that you are trying to estimate, okay, will have noise in it. So when you are writing it like this, okay, you have to, so when you are writing like this, let's say the log of y is equal to log of, so let's say log of f of x minus u, and again there is no noise. So the idea is that only you have to add noise, and stochastic forget does that. So what you are doing is, you see that we have now added a noise term, b. So you have u in there, and then you have b. So u is inefficiency and b is noise. So the question is that the regression that Professor Rafford was showing, we had one error term, b, right? But now you have two error terms. One is b, the other one is e. So this is the most challenging part. That means how do you separate? You don't observe that, and nothing is observed other than y index. So the question is that you are trying to estimate a relationship, okay, and again eventually get a measure of u without observing them or without separating u from b. You can run a regression and get a composite measure of b and e. But the question is that how do you separate u from b? And if I'm drinking tea or coffee, and then I said, well, milk is added. Now, how do I'm drinking it and I see that, well, milk is added, but can I take the milk out? Okay, so this is something like that. We are seeing these two things together, but ultimately we want to, get an estimate of U, meaning that we have to separate U from B, and that's what we do in stochastic frontier. So how do you do it? Well, we introduce distribution assumption. So this is where the technicality starts. Okay, that is the way you can separate U from B, okay, by using some distribution assumption. What do you mean by distribution assumption? Certain things you know or you have heard. So if I just say, well, B is normal, everybody knows normal distribution, right? I mean, doesn't matter whether you have taken a course or not. Normal distribution in the US, everybody knows what a Bell curve is, right? So that's your normal distribution. Okay. So if you draw if I do it something like this, so this is a normal distribution. Okay. So it goes from minus infinity to plus infinity, and again like that, you can have a zero mean. So this is a Bell curve or symmetric distribution. Okay, normal distribution. But what is U? U is positive, right? So you cannot be normal distribution. Normal distribution meaning that what you will have a negative value and positive, yeah, right? Okay. So if it is a inefficiency one-sided, then it has to be something different. So what you do is you can just think in terms of a normal distribution like this, cut it in here, and then erase this part. Oops. Okay. If I look at this, then again, you can say, well, that's U, because U is taking only non-negative values. So this is normal, and this is something else. Right? We just say, well, this is normal, and this is half normal. Why half normal? Any idea? I just took half of it, right? I took the other half out. I took the positive part of it because so now again we are mixing two things. One is the full normal, and the other one is half of normal. So we are adding those two things. So if you're a statistician, you will be able to see that, well, okay, I know that one has a full normal, the other one is only half of it. So there must be some way to distinguish between them. And again, like, the technique that we'll be using is coming from statistics. So this is a mixture of a regular normal and a half normal. Okay? Or sometimes we use the word truncated normal. A normal is truncated at 0. Okay. Okay, so let's just take a break in here because as I was saying that even though it's in university, the time limit is 1 hour. So don't understand. So I have to talk to these people that you cannot run an university with a time limit on this type of thing. Okay, so let's just take a break for 15 minutes or so. I don't know whether you can get coffee or tea. Okay, I think all those people are organizers are outside. So, is there any coffee for you guys or what? Or if there is no tea or coffee, just take it back and we just because otherwise it's too much. Right? Okay, so let's just take a break for. Is there any coffee for them or break or?
So current busy break.
Okay, so, sir, you should request from our side that please, I think up to
Oh, okay, okay.
up to 15 minutes more, and then
Then
then the tomorrow we will continue from this slide.
okay, okay.
Okay, at 9:30.